Hi there, Mrs. Thompson here. We're going to talk about covalent bonding today. We'll talk about covalent bonds, the elements involved in covalent bonds, and naming covalent compounds. First thing, what is a covalent bond? Well, we talked before about atoms either transferring electrons or sharing electrons. In a covalent bond, they share electrons, and they do this to gain stability. And so what I've written here is, in order to gain stability, atoms in a covalent bond share electrons to complete their valence shell with 8 valence electrons. So each element, each nonmetal, is going to share electrons so that they have a complete octet. We call this the octet rule. And so this picture down here of 2 fluorine atoms, these 2 fluorine atoms are sharing their valence electrons, just 2, so that each of them can have an octet in their outermost shell. Okay, you need to know that covalent compounds are made up of 2 or more nonmetals. So it's nonmetal plus nonmetal or more. They're also called molecules. And so what you have here is a picture of hydrogen and oxygen forming water. The electrons in their valence shell, those are the only ones that are being shown here. The electrons in the valence shell are being shared throughout the hydrogen and the oxygen. Hydrogen comes in there with 1, and oxygen comes in there with 6 valence electrons. So it requires 2 hydrogen for every 1 oxygen. Okay, we need to know the properties of molecules. So you need to know that molecules, unlike ionic compounds, have low boiling points and low melting points. That means they aren't as hard to separate. It takes less energy for them to move away from each other. Most of them do not dissolve in water. And there are some things that do dissolve in water, but most of them are insoluble, is what we call it. They tend to be gases or liquids in room temperature. And they do not, or they very weakly conduct an electric current. Okay, this should be the opposite of what's going on with ionic compounds. And so you have this little table here. You don't have to draw it, but it is a lot of good information in that the boiling points of covalent compounds are lower. They tend to be soft and squishier. They tend to be more flammable, and they are not soluble in water and do not conduct an electric current. All right, we're going to learn how to name molecules. This is nomenclature again. And so there's some simple steps to do this. First, you name the elements that are in the compound. Remember that we're doing this to things that are made up of only nonmetals. Okay. We add prefixes to indicate how many of each atom we have. And we change the ending of the second element to IDE. So in this example here, the 2 elements are carbon and fluorine. Fluorine's changed to ide. And there are 4 fluorines, so it's carbon tetrafluoride. Okay, here's a table of prefixes, which you will definitely need. Just tells you how many of each atom you have. So if you have 1 of the atom, it's mono. Then 2 di, 3 tri, pretty normal. 4 tetra, 5 penta. 6 is hexa. Now, it's this right side that tends to get students a little messed up as far as not knowing what those are already. I like to memorize hexa by thinking that 6 has an X in it, hexa has an X in it, so hexa is 6, whereas hepta is 7. And then octa, like an octopus, has 8 legs. Octa is 8. Nona, 9. And deca, 10, like a decade. Okay, when naming molecules, there are a few exceptions you have to keep in mind. One is that we never use the prefix mono for the very first element. You think about carbon dioxide. Carbon doesn't have mono carbon dioxide. We just call it carbon dioxide. So the first element never uses the prefix mono. And this is when you're naming binary molecules. Okay, we will drop the last letter of A or O from the prefix when naming any oxide. This is so that it doesn't sound funny when you're saying it, like deca oxide. It's kind of hard to say that, so we just change it to dec oxide, which is still kind of hard to say, but here we go. All right, so let's try some examples. And so with these are all molecules. I know that because they're made up of nothing but nonmetals. Now we're really going to focus on just naming binary molecules, which is just 2 elements involved. There's some other rules for naming organic molecules, which we will probably not get time for, but let's worry about these. So here I'm going to follow the rules in that I'm going to name the 2 elements involved. You might want to wait till the end to write this stuff down. So phosphorus and sulfur, the 2 elements I'm looking at. For sulfur, I'm going to change that name ending. Remember in the rules it said to change those to IDE for the second element. So this is phosphor and sulfide, phosphorus and sulfide. And then we're going to add prefixes to state how many of each we have. So we have 4 phosphorus, and the prefix for 4 is tetra. And we have 8 sulfurs, so that's octa sulfide. So it's tetra, phosphorus, octa sulfide. Next one, N and O. We'll name the first element nitrogen, second element oxygen, which will change to oxide. And then however many there are, there's 1 of each. But there's a couple of issues here, a couple of those exception rules that we need to look at. One is that you never put mono on the first element. So we'll get rid of the mono. The other is when you're naming oxides and you have a prefix that ends in an A or an O, you drop the A or the O in the prefix. So instead of, next we have N4O10. Let's do this all at once. We have 4 nitrogens, so that's tetra nitrogen. And we have 10 oxygens, that's deca oxide. Now remember, when we have that double prefix on an oxide, or double vowel on an oxide, we'll drop the prefix vowel. So this will be tetranitrogen dec oxide. Not too bad. I added this little joke here. Okay, so now you should get this joke. It says, "Look, Mom, carbon tetrafluoride." Hopefully your grades don't look like this. I just thought it was cute. Okay, here are some special elements on the periodic table that you do need to be able to name, and these are called the diatomic elements. The reason why they're called diatomic is because they tend to exist in nature in pairs. So we never really find hydrogen as just H floating around like we would a neon gas atom. Neon would float on its own individually, so it'd have its own little atom of neon floating around, and more atoms of neon floating around. For hydrogen, what you have is a hydrogen bonded to a hydrogen, bonded covalently, and those 2 float around. Same thing with nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. What happens is they're so close to having their octet, they decide to share instead. And so here are the 7 diatomic molecules that you have to memorize. There are a couple of ways to memorize them. The first way works like this. What you do is there are 7 diatomics. First one is here at hydrogen, and then starting at atomic number 7, nitrogen, it forms a 7 right here. 2, 3, 4, 5, 6 elements form that 7 plus hydrogen. The other way to memorize it is by the way I've written it. We just state it out loud. Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And so it just sounds like a funny name of some scientist or something, but I've always memorized it as Brinkelhoff. And so I will state, sometimes just remember Brinkelhoff. Okay. For these diatomic elements, when you're naming them, here's what you do. So it says, when these elements are in their diatomic form, meaning they're not combined with any other elements, they're simply just F2, Cl2, Br2, I2, and so on. You name them by their element name. So over here, this molecule is just bromine. This is iodine. So even though it's just the element's name, it's referring to the iodine molecule or the nitrogen molecule. Here you can see their electron dot structures. You can see that they're sharing electrons in order to form these elements or diatomic molecules. Here's an example. N2 would just be called nitrogen, and that's only when it's by itself. Okay, if I had N2I, that would mean nitrogen is combined with iodine, and so that would no longer apply. It's just when they're by themselves. Okay, here I have a little warning about the dangers of dihydrogen monoxide. See if you can figure out what dihydrogen monoxide is. Here's the warning. It's odorless and colorless. Accidental inhalation of DHMO may be fatal, and prolonged exposure to its solid form may cause severe tissue damage. Symptoms of DHMO ingestion can include excessive sweating, urination, and possibly bloated feeling, nausea, vomiting, and body electrolyte imbalance. So it sounds like some terrible stuff, and all dihydrogen monoxide is water. Which brings me to this. There are some compounds that just have a common name and everybody knows it by this common name, so they don't actually use their systematic name. And so here are the molecules that instead of using the naming rules for, we just simply name it by their common name. First one is DHMO, dihydrogen monoxide, which we just call water. So never write dihydrogen monoxide, just write water. NH3, it's not nitrogen trihydride, it's ammonia. And our last one, O3. See if you remember this from Earth Science, if you took Earth Science, it's ozone. And that completes the notes. Bring some questions to class if you have.